Welcome to the Intel Scaling at the Edge video series. In this video, we'll learn about the Scalable Edge Cloud platform from Lanner. Joining us is Sven Freudenfeld, the CTO of the Telecom Applications Business Unit at Lanner Electronics. Sven, take it away.
Thank you and welcome to our short session about the Scalable Edge Cloud platforms from Lanner Electronics. We've been building appliances at Lanner Electronics for more than 35 years, traditionally in the network security space. With that, we have been focusing over the last couple of years for building appliances for the network infrastructure, including disaggregated networks. You can see here we have three categories of platforms. On the left side is primarily regarding universal CPE or universal customer premise equipment, which is towards an enterprise with multiple locations, where we build appliances with built-in 5G devices and Wi-Fi connectivity. And the mid-range is focused towards the industrial sdwan and industrial universal CPE market, which is gaining more traction specifically in oil and gas, as well in other vertical markets. And on the right side, you will see a portfolio which is aiming towards the service provider edge. And the service provider edge contains networking, computing, acceleration, and is scaled towards a telco environment where we provide great flexibility for the edge locations in the service provider network. One area of investment we've done over the last 7 years is towards universal CPE or universal customer premise equipment for sdwan. So there are two areas of focus: universal CPE with hosting multiple VNFs on a single appliance, and sdwan operating a security framework on a bare metal on these appliances. And we built solutions together with Intel, which are scaling from small, medium, large, and extra large. So there are multiple elements to be built in, either Wi-Fi connectivity, LTE connectivity, broadband connectivity, but also the management aspect on that. So these platforms are deployed in masses with multiple locations. And on the smaller side, we've seen also an uptick in the use case of working from home for some of the enterprises where they're providing network security to the workforce at the specific location. Another use case what we have seen and which has been adopted in the market is to be deploying new protocol layers and providing a appliance which can scale with compute networking at the service provider edge. And in particular with a variant towards multi-access edge computing, where we are leveraging the Intel Buffer Tofino to have an open programmable networking infrastructure built into the edge appliance, providing segment routing with 6 or SRv6 service chaining. So that allows to scale multiple applications as well resources at the edge, and allows to deploy rapidly virtual firewall, virtual DDoS, IPS, IDS, or even the analytics part of some of the framework for networking. And with that approach, by using an open, scalable appliance, we are able to reduce the cost significantly, in particular the operating costs, because everything is pre-integrated. And we are also able to reduce the power consumption, the footprint, but also the operating costs in terms of cabling, wiring, and so forth. The next area is radio access networks, and radio access networks is going through a change in the industry. There is a move towards the Open RAN initiative. Open RAN means that These are based on white box appliances, meaning a generic appliance based on the Intel architecture, which provides acceleration for the distributed unit, but also for the centralized unit, to host some of the applications at the edge location close to the cell tower, and at the same time providing routing and switching towards the backhaul. It requires multiple layers of integration, including timing for IEEE 1588, acceleration using FPGA, but also networking by using an open programmable switch ASIC onto this. This is still in the beginning, and we will see more traction coming towards over the years. Another area is, of course, the security, scalable security parameter. And we have a use case where we are basically providing this platform as a gateway between the hyperscaler as a security gateway with packet steering and load balancing, and the regional network. Because of the flexibility and because of the SDN framework, including containerizing the workload, we are able to create instances dynamically and therefore scale at the edge location by reducing the need by adding additional hardware elements into a location and leverage the fully integrated platform into it. The carrier-grade platform, the multi-access edge compute platform, is been developed over time, and we have great deployments so far. We are extending the platform in leveraging the next generation Intel platforms as well, in order to leverage the same architecture for any up and coming next generation CPUs, and therefore we are able to scale and help the service provider to scale the solution as well. And our latest flagship is a edge device, which is in particular built towards an open concept, which is providing also programmable switch ASIC with the Intel Tofino with the P4 capability, IEEE 1588 for timing, but also multiple 100 gig connectivity to the backplane towards the switch. Everything is front loadable, and because at the edge location you don't have a luxury of having rear access in some of the locations, and therefore we have great scalability by also adding network accelerator cards into it, either an OCP, a standard OCP form factor NIC, or a standard PCI Express cards as well. So this is a quick overview. In case you'd like to learn more about that, please feel free to reach out to Lanner Electronics by contacting by email to contact@lannerinc.com.